Okay, so to learn all about time dilation, we gotta start from the scratch. So hear me out. Now Einstein, he was cooking, alright? He was cooking at the top rate of the burner. So he stated a theory called Einstein's special theory of relativity. So here's what it stated. So this special relativity is an explanation of how speed affects mass, time, and space. So this theory also includes a way for the speed of light to define the relation between energy and matter. So let's go. So before that, we have to learn about the relativity of time. Time is universal, but that's not how it should be. Time seems to be a universal flow, seems to be in a universal flow, having a rhythm of a tick-tock, but it doesn't have to. The special theory of relativity, Einstein determined that time is relative. In other words, the rate at which time passes depends on your frame of reference. Your frame of reference defines and determines how your time passes. So I'll give you an example of frame of reference. Alright, let's say that I'm in a spaceship traveling with the speed of light, let's say near a black hole. So I have a clone here on Earth. So he's on Earth standing. Let's say he's sitting in my room. So this clone here has a watch. So do I. But for him, the watch is gonna move faster. Whereas for me, it's gonna move slower. That's how relative time is. But just because I'm near a black hole, the more the mass of a celestial body, the more faster the time moves. So I was near the black hole. So if I was near the black hole at the speed of light, my time is moving slower than the time here on Earth. So the clone is gonna age way faster than me. I'm gonna age just minutes while I come. Just minutes or hours, let's say hours or days, when I come back to Earth. But then my clone here, he's gonna be aged by years. That's how crazy it is, ain't it? Einstein called this the theory of relativity. Einstein also called this the twin paradox. So this twin paradox is literally what I gave as an example. So here, the mass of the black hole is way more, because black holes are massive, whereas Earth's mass is minimum 1,000 times lower than the mass of the black hole. So that's why he aged way faster, whereas I aged way slower. Alright, so all this time we were talking about traveling to the future, but why can't we travel to the past? There's a catch. Let's say I'm making coffee, alright? So I have mixed coffee powder, sugar, milk conditioner, and I'm going to mix it with a spoon. I have mixed it. Now it's mixed. So even if I wanted to, I can't unmix it. That's how when the Big Bang occurred, the universe was set in an order, alright? So this order went so on, in which time can't go back, whereas time can bend, can ripple, can do almost anything except go back. So if it's ordered, you can't unorder it, right? That's why we can't go back in time, whereas we can go front, we can go forward in time. Crazy, right? See, I might be totally wrong. We might be totally wrong. Our whole understanding about the universe might be totally wrong. But one thing that we all can be right is, everything is possible. Nothing is impossible. See you in another video.